Hi, in this video we're going to find an unknown side length by using a combination of trigonometry with exact trigonometric ratios. I'll explain what I mean by that in a second, as well as using Pythagoras as well. So we've got this triangle here, right angle triangle, and we've got this right angle triangle here. We're trying to find the length of KM, which is this length there. Let's just call it X, and that's what we're trying to work out. Now, we can't find X immediately from this triangle because we don't have enough information. We've got this length of 2, but we don't have any other information about this triangle other than it's right angled. But this triangle here, we have this length here, and we've got this angle. That's enough to work out all the sides and angles. Now, it'd be great to work out this length of that triangle because this length is shared between the two triangles. And if we know that length, we can then use it in this triangle here. So let's try and work out that length. We're going to call it y, and we're going to try and find that out first. So let's just draw out this triangle separately. We've got the 30 at the top, we've got the 2 here and the y. And remember, we've got to use trigonometry here because we've got two side lengths and an angle involved. So we use trigonometry. So remember what we do first. Relative to this angle of interest, the 30 degrees, the angle of interest is a labelled angle that's not the right angle. We label these sides where we know the side lengths, so it's y and 2. So this side here is the hypotenuse of the triangle. It's the longest side, so I label it as h for hypotenuse. And this side here, this is adjacent to, next to that angle of interest, so we label it as a for adjacent. And then remember, we use SOHCAHTOA to work out what trigonometric ratio to use. So SOHCAHTOA is the mnemonic. We're involving A and H, so it's this one here. So we're going to use cos. C stands for cos. We saw how to do this in a previous video. So cos of the angle of interest, theta, is equal to A over H. So the angle of interest is here, that's the theta, right? So let's just substitute into that. Cos of the angle of interest, which is 30 degrees, is equal to A, which is 2, over y, h, which is y. And then because the variable's in the denominator here, remember the quick way of dealing with this is that you can swap the thing in the denominator and the result of that division. So you can swap this and this. I explain in other videos why that works, so it's not just magic. So y is equal to 2 over cos 30. Now, I said earlier that that we want to involve exact trigonometric ratios. And what I mean by that is when you have sine, cos, and tan of nice angles. So I've got a table up here from a previous question. You can see I've got this nice table here. We've got sine, cos, and tan of 45 degrees, 30 degrees, and 6 degrees. So you could try and memorize all these values if you want, but we can work it out from scratch. Remember, if we want sine, cos, and tan of 45 degrees, then we take a unit square, so a square of length 1, and just cut it in half. And if you want to find sine, cos, and tan of 30 or 60, you take a equilateral triangle of side length 2 and then cut it in half. So let's see. We've got cos of 30, so we're going to have to use an equilateral triangle of side length 2 to work out what cos of 30 is. So it's side length 2, you cut it in half like this. And now, if that side length is 2, then that side length is 2 because it's equilateral. So that is half of it, which is 1. And if you use Pythagoras theorem, I'm just going to skip the steps, but basically this length is root 3. The quick way to get that is that because this is one of the shorter lengths, you do the square root of the difference of the squares. So you do 2 squared minus 1 squared, which is 4 minus 1, which is 3, and you square root it. Now, what about the angles in this right angle triangle? Well, this is an equilateral triangle, so the interior angles are 60, that's 60, 60, etc. And then because these angles add up to 180, that's 90, that's 60, the remaining angle would be 30. Now, we're trying to find cos of 30. So the angle of interest here is the 30. And remember that cos of theta is equal to A over H. We saw it earlier from here, right? So we're trying to find cos of theta. The theta here is the angle of interest of 30. So if we substitute in, we've got cos of 30 is equal to the adjacent. Now, the root 3 is adjacent to next to the 30, so it's adjacent here. So that's the root 3 over the hypotenuse. The hypotenuse is the longest length, which is that 2 there. So it's root 3 over 2. But as I said, you could try and memorise that table from earlier. So cos of 30 is root 3 over 2. So now this, so we come back to this, y is equal to 2 over, and then cos of 30 is root 3 over 2. Now, I don't like fractions within fractions, so what I'm going to do is I'm going to multiply top and bottom of this outer fraction by the denominator of the inner fraction. So I'm going to multiply top and bottom by 2. So the 2 times the 2 at the top is just 4. And then the times 2 here cancels out this over 2, just leaving the root 3. So we get 4 over root 3. So that's great. I now know that this y here is 4 over root 3. And now we can concentrate on this other triangle here. Now, how can we find x, which is the side length we want? Well, we know this side length and this side length here. And remember, when you're involving all 3 side lengths rather than any angles, we can use Pythagoras theorem. So the way we use Pythagoras is we label the 2 shorter lengths a and b, so make that a and b either way around, and the hypotenuse is the c, the longest length. So let's just substitute that into Pythagoras. Pythagoras theorem is that a squared plus b squared equals c squared. So we've got a is 2, so 2 squared, plus the b is 4 over root 3, so 4 over root 3 all squared. Notice my use of brackets there because we want the whole fraction squared, equals c squared. And our c was x, so it's equal to x squared. So let's just simplify this. 4 squared, 2 squared is 4. And when we square this fraction here, we square the top and the bottom. So the 4 squared is 16. And the root 3 squared, well, the squared cancels out the root, so you just get 3. 16 over 3 equals x squared. And then, well, we could write the 4 as 12 over 3, because that enables us to now add these fractions. 12 thirds plus 16 thirds is 28 thirds. Same denominator, we add the numerators. And now we can just square root both sides. So x is root 28 over 3. And what form does it want the answer in? This is without using a calculator. Now, there's not much you can do with this other than, well, we can simplify this third at the top. If you root a whole fraction, you root the numerator and root the denominator. Now, root 28, we can simplify that because it has a factor 4. So remember, you find the biggest square number that goes into the 28, and the biggest square factor is 4. So we could write it as root 4 and then root, well, 4 times what is 28? It's 7. And then root 4 is 2, so it's 2 root 7 over root 3. Now, if we wanted to simplify it further, we could rationalise the denominator. And remember, to do that, you multiply by whatever surd you have at the bottom. So we times top and bottom by root 3. So the numerator becomes, we got the 2, and then you've got the root 7 times root 3 is root 21, because 7 times 3 is 21. And then root 3 times root 3 at the bottom. Remember, when you times the square root by a surd, remember, when you times a surd by itself, it just cancels out the root, so you just get 3. And that is the best we can do.